Hi everybody. Sorry for the delay. We had open house tonight and I had intended to get this video out sooner, but we got a little busy. So this lesson ran a little long, so I actually split it into two videos. This one will be much shorter, less than 5 minutes I'm hoping. So this is part 2 of lesson 6, and we're talking about compounds, elements, and mixtures. All the matter in the universe can be classified into one of those 3 categories, and we were talking about mixtures a while ago. Remember, mixtures are impure matter. There's more than one type of atom or molecule present, and they're classified based on how they appear. So there are mixtures that look like only one thing, and those are called homogeneous mixtures. And then there are mixtures that look like more than one thing. You can actually see visible parts to the mixture, and those are classified as heterogeneous mixtures. So I gave you a couple examples of homogeneous and heterogeneous mixtures. I do have, so you can see with your own eyes, this is a mixture, and you can see 2 distinct parts to the mixture, and therefore this is a heterogeneous mixture. It looks like there's more than one type of matter here. Okay? Eric and Ellie are here, so they may be making some cameo appearances. All right, what do you need to know about mixtures? Mixtures are not chemical combinations, because if it's a chemical combination, it's a compound. Mixtures are physical combinations of substances, and therefore they are physically broken down. Okay? So you can break apart or separate the components of a mixture physically. For example, if I had salt water, I could separate the components of that mixture by evaporating the water. That's a physical process. If I had pepper and salt in a mixture, I could add some water, dissolve the salt, and the pepper would float, and I could skim it off, and I could separate the components of that mixture physically. I'll be demonstrating for you next week other physical methods of separation. Since you can make a mixture any way you want, if you want to make iced tea, you can put in a lot of water and a little bit of sugar, or vice versa. They have a variable composition. Stop it. Go sit down. They have a variable composition. And to have a variable composition means that it can change. It's changeable. You can make, if you're making a mixture of salt and pepper, there's no rule that says you have to put in this much salt and this much pepper. You can vary it any way you wish. Okay? You can make a mixture more than one way. Mixtures, therefore, since they can be made more than one way, do not have formulas. I can't give you a chemical formula for salt and pepper mixed. There isn't one. Okay? And as you know, they are the only form of matter that can be heterogeneous, or they can be heterogeneous. Oh, heterogeneous or, excuse me, homogeneous. I want you to add one thing, and this is different from compounds. When elements get together to make compounds, their properties change, and they have properties then only of the compound. However, when elements get together to make a mixture, they retain their individual properties. That's going to be significant. So I have some pictures here for you of some mixtures. You can see up here, this one, there's different atoms, so there's more than one kind of atom, and you can see that it's not uniform. So the red is not evenly dispersed throughout the gray. This is an example of a heterogeneous mixture. Okay, again, down here, you see my mixture of salt and pepper in there. And again, that is heterogeneous. You can see more than one thing. There's more than one visible type of matter present. Contrast this to the salt water that's next to it. And even though there's 2 components, it only looks like water. It looks homogeneous. So this is a homogeneous mixture. All solutions, like salt water, are homogeneous, and this is heterogeneous. And then I have have my favorite meal ever. This looks like some salad and with some great mozzarella cheese and fresh tomatoes. I'm kind of hungry. And this is obviously heterogeneous as well. You obviously can see different parts of this mixture. Okay? So really, if it has uniform properties, it's homogeneous. If it doesn't have uniform properties, it's heterogeneous. If it has a fixed composition, it's a compound or an element. If it doesn't have a fixed composition, it's a mixture. So these two here are mixtures. Okay? If you notice here, there's only one type of atom, and therefore that is an element. And if you notice in this picture, there's different atoms bonded. How can you tell they're bonded? They're stuck together. This is a compound. Okay? So what I'd like you to do for class on Friday is complete the labels to these boxes. So I'd like you to draw these boxes on your paper and then classify them as either a compound, an element, or a mixture. Okay, so you're going to draw all 4 boxes on your sheet of paper and you're just going to label them. Okay, so if you think this is a mixture, you'll label mixture. I don't know what you think it is. Okay, if you think it's an element, you label it element. Okay, but your job is to draw the boxes. Oop, I guess I have to move those back. To draw those boxes and label it whatever you think it may be. On that note, it's late, my kids are getting squirrely, and I need to get them home and go to bed. I will see you in class tomorrow. Have a great night. Bye-bye.